All right, class. So here's the Chapter 11 review, at least the first half of the chapter, and hope that this material is understandable for you. I think the biggest key is how you punch it in your calculator, and so let's go ahead and get into it. All right, so 1 and 2 says find the area of each triangle to the nearest tenth. So when you're looking at area, the key to everything, of course, is the formula. So the area of a triangle equals 1/2 AB, and then the sine of the angle C. So if we were to look at number 1, if this were A and this were B, that angle would be C, and we're in great shape. So the area is 1/2 side A, 18 feet, times side B, 10 feet, times the sine of the angle C, and that's 30 degrees. All right, so 1/2, and we could even get an exact value for this if we were to use the 30-69 triangle, but I think sine of 30 is a half anyhow, so it does not matter. So I like to punch the angle in first on this. So I'm going to do the sine of 30 degrees. I like to get that out of the way. And then it's going to be times 9 times 10 or times 90, right? And this thing is exactly 45 square feet. Don't forget the units there. Area is always in square units. In this case, we had feet, so it would be square feet. All right, let's take a look at this problem number 2. So I'm looking at the values. Because I know this value, I'm going to call this A. And because I know this value, I'm going to call this B. And notice here now, therefore, angle C is there. Okay, so when I go to run my formula, area of a triangle, and again, I'm using this formula right here, right? Equals 1/2. My A is the 13 meters. My B is the 25 meters. Now here's the key. You got to get angle C. And we all know that the three angles of a triangle equal 180. So I just need to do 180 minus 120 minus 27. So 180 minus 120 minus 27, and that gives us a 33-degree angle. So that's going to be the sine of 33 degrees. And again, I like to punch that in first. 33 sine times 25 times 13, and I'm just going to divide by 2. And rounding off to one decimal place, I get 85.5 meters squared. All right, 85.5, 88 point, if I could read my calculator correct, 88.5 meters squared. Okay, all right, so again, be careful. Example 2 is a good example because you have to think about where each component is that you're given, and the formula only works in that in those correct sides and angles. All right, area of a triangle. Next questions. Classify each set of measures as angle, angle, sides, angle, side, angle, side, side, angle, side, or side, side, side. Then find the indicated length or angle measure to the nearest tenth. Okay, so first off, we have to look and see what we have. So we're just labeling, look, here's an angle, and here's a side. So notice how they're directly in line. So we have an angle, we have a side, we have an angle. So number 3 is going to be angle, side, angle. Let me go ahead and get this out of the way for number 4 as well. Notice here we have a side. We have a side, see they're in a row, and we have an angle. So this one is side, side, angle. All right, so those are the first parts. Let's go ahead and get into solving for the unknown value. So when I look at this, my first thought is this. This is not a right triangle. It's not a right triangle. Therefore, I cannot use right triangle trig. However, I can use the law of sines or the law of cosines, and I always want to try the law of sines first, see if I have the information I need. Now, again, whenever I do the law of sines, I like to put what I'm looking for in the top left. It's the easiest way to do the proportion. Do you have to do it that way? No. Is it the easiest? Yes. Okay, so x is a side, so it should be over the sine of the opposite angle, which is 73 degrees. See how that's opposite? And then I do know the 4, but notice I need the angle opposite the 4. So here's another scenario where knowing that the 3 angles of a triangle equal 180, this angle right here is going to be 180 minus 85 minus 73. So what is that? 180 minus 75, punching into my calculator, minus, oops, I said 75, didn't I? 180 minus 85 minus 73 equals 22 degrees. So this is going to be over the sine of 22 degrees. Okay, and I'm ready to roll. Things on the bottom go to the top across the equal sign. So this is going to be sine 73 degrees. So here's basically what I'm punching. 4 times the sine of 73, and then I'm going to divide that by the sine of 22. So let me just tell you what the top is. The top is now 3.8252, and I gotta divide that by the sine of 22. And sometimes you're gonna have to hit enter at the end. And I got x equals 10.2. Normally we're gonna round to 1 decimal place, and that is correct. And I should probably use my approximately, right? So x is approximately equal to 10.2. So 2 solutions, 2 answers, angle side angle, and then x approximately equals 10.2. All right, number 4. So now I'm looking for an angle. So the sine of alpha over its opposite side, which is the 5, will equal, what other angle did they give me? Here, I got to erase. Is that a 124? That is a 124. So 120 sine of 124 degrees over the opposite side, which is 11. And so again, real easy. How do I move this 5? Multiply both sides by 5 over 1. And so I'm going to punch in sine of 124 times 5 and divide by 11. So sine 124 times 5, that number's like 4.1 something. And then I'm going to divide by 11. And then here's the ending now. And here's the key. You're finding an angle. So let me write it this way. So alpha is going to be sine to the negative 1 of the sine of 124 degrees times 5 divided by 11. So make sure you understand that the angles, right? The negative 1 buttons get you the angles. So it's sine to the negative 1, and I got 22.1 degrees. So alpha is approximately 22.1 degrees, and there's your second answer to number 4. All right, so side-side angle, and then approximately 22.1 degrees. All right, again, we're classifying. So let me take a look, see what I got here. I think I'll do it in green. So I have a side, don't have any angles. What in the, is this a misprint? No, okay. This is kind of a weird problem. Actually, they gave us the right angle. So this is a side angle side. And this is right triangle trig. All right, that's a tricky question. All right, almost got me. So this is side angle side, and it's a right triangle trig. So we're back to last chapter, right? We are back to last chapter. If you're going to solve this. So I'm going to look at the angle. I'm given the opposite, and I'm given the adjacent, and therefore I would decide to use the tangent of theta is going to equal the opposite 4 over the adjacent 7. So the measure of theta is going to be tangent to the -1 of 4/7. All right, that was tricky. They were trying to trip you up. All right, so tangent to the -1. I got theta is approximately 29.7 degrees. 29.7 degrees. Tricky, tricky, tricky. Okay, but that is what it is. All right, how about what kind of triangle do we have here on number 6? Here again, we have a side, angle, side. So once again, we have side, angle, side. Only on this one, we're definitely going to use the law of sines or the law of cosines as we try to figure out the value here. And if you look, I always think about the law of sines first. So let me use some color. So I'm given this angle, and I'd have to find z. Okay. So those two go together, but then I know another side, but I'd also have to know its opposite angle. And I don't know either opposite angle. So guess what? I'm going to have to use the law of cosines here. So in this one, we got to use the law of cosines. And so let's write out the law of cosines. So z squared equals, I'm going to use A and B here. It's fine. I'm just going to leave the C. These letters don't matter. A squared plus B squared minus 2AB, right? And then cosine. I can't tell you how many students put sine there, but this is the law of cosines. And then cosine of angle Z. So let's see if we have enough things. So just to be clear here, to get to Z, it's going to be the square root, right? Take the square root of both sides. All right, so now it's a substitution. Don't forget your square root. All right, and A and B are interchangeable here just to make life easy. I'll call that angle A, and I'll call that one angle B. So 4 squared plus 6 squared minus 2 times 4 times 6 times the cosine of 41 degrees. All right, so be careful in punching this. As I said in the video, I like to punch this part first. But again, it's up to you. You got to learn how to punch it in to make it work for you. All right, times 24 times 48. All right, and that's a negative plus 36 plus 16. I got like 15.7, and then I got to hit my square root button. And so hit the square root button. I get 3.97, so if I round off, that's going to be 4.0. All right, this is real close to an isosceles triangle, but it's not quite. It is not quite isosceles, but it's close. So 4.0 is the value of side Z. And don't leave it just 4, right? It's a round off. We round it off to 1 decimal place, so I want to round it off, and I want to get 4.0. All right, law of cosines on number 6. 7 and 8, solve each triangle, round answers to the nearest tenth, list all possible solutions for the ambiguous case. All right, so we have to be aware of the ambiguous case as we go through. Is every triangle ambiguous case? No. Now, I told you, make sure you draw a triangle. So the way I draw my triangles is I always like to do the angle first. So 38 degrees, I don't know, something like that. Put the 38 there and put the A there. Now, I also have to do an angle B of 72 degrees. 72 degrees. All right, so 72 is less than 90. So how about if I come like that and call that 72 and put the B there? Okay, and then the 12 therefore would go there. Now your picture may not look exactly like mine. But the A has to be 38 and the B has to be 72, but But here's the point I want to make. Let me see if I can do this. Hold on a second. Okay, so maybe you put angle B there, like that. Or, I don't know how you did it, but this thing can be spun, right? It can be spun. And so there's different ways, but angle A has to be 38, B has to be 72, and the side opposite B has to be the 12. You have to do that. Therefore, then, this is side A. This angle has to be angle C, and this is side little c. All right, so to solve my triangle, I like getting the angle first. I know angle C is going to be 180. So the measure of angle C, I should do this in green. C is going to be 180 minus 38 minus 72. So punch that out, 180 minus 38 minus 72, and I got 70 degrees. And that's exact. So the measure of angle C equals 70 degrees. Okay, so I found my fourth part. There are 6 parts, right? 3 angles, 3 sides. And now I have 2 sides to go. I'm going to do side A. I think is the easiest way to go. So side A, I can use law of sines over the sine of 38 degrees equals the side B, which is the 12, over the sine of its angle, 72 degrees. That was supposed to be blue. All right, oh well. Sine 72. Okay, and then again, this is easy. Goes from the bottom, goes across the equal sign to the top. So the sine of 38 times 12 divided by the sine of 72. And I got approximately 7.8. So A is approximately 7.8. Okay, so I got one more value to go. I need the value of C. And again, I think the law of sines is the easiest way to get that. C over the sine of 70 degrees. And I always like to use the values that were given. Now I could use the A, 7.8, and the 38, but I was given the 12 and the 38 degrees, and I prefer to use what I was given. All right, again, things in the bottom go to the top across the equal sign. Why? Because you're multiplying both sides by sine 70 over 1. All right, 12 times the sine of 70 times 12 divided by the sine of 38. And that is punch that one more time. Sine of 70 times 12 equals, and then 38 equals, and I'm getting 7.4. Something is off here. All right, let me look at this one more time. C in angle C is definitely 70 over 12. Oh, 72. See, you got to write the right angle B is 72, and I wrote angle A. Thinking, what was off here? Okay, my bad. Okay, let's punch this one more time. Sine 70 times 12 divided by the sine of 72. And there we go. All right, so C equals approximately 11.9 as we round off. All right. Okay, so we found the other 3 parts and we solved the triangle for number 7. All right, number 8, same thing. We want to start off with a picture. Again, I like to start with the angle given. 78 is a little bit bigger angle, probably could be even more than that. Also given a C of 46. I could put C over here, or I could put C over there. It really does not matter. It can go either place. For my sake, I'm going to stick it here. So I stuck C there and I stuck A there, and they gave me side little c, so 3. So we're going to need to find side A, angle B, and side B. Okay, once again, angle B is the easiest first thing to find. The measure of angle B is going to be 180 minus the 78 minus the 46. So 180 minus 78 minus 46, and that is 56 degrees. And that one's exact. So the measure of angle B equals 56 degrees. Okay. I can use the law of sines to get A. So A over the sine of 78 degrees. And I was given C, little c as 3, over the sine of C of 46. Okay. Things in the bottom, go to the top across the equal sign. So sine of 78 times 3 divided by the sine of 46. And I got 4.1. So we got approximately 4.1. Okay, so we got our angle, we got side A, and the only thing left is side B. And again, I'm going to use law of sines. B over the sine of B we found to be 56 degrees, again equals C3, what I was given, over the sine of C, 46. And now, again, sine 56 goes to the top across the equal sign. 56 sine times 3 divided by the sine of 46. And I got approximately 3.5. So B approximates 3.5, and there's the solving for number 8. Okay, any ambiguous case on any of these? And the answer there so far is no. So none of these were ambiguous. All of these were straightforward and just those solutions. Okay, 9 and 10. Round answers nearest 10th. List all possible solutions again for the ambiguous case. So once again now I have a triangle and I've got to draw it. And all I have are side lengths. Okay, that's all I have. I have side lengths. So I got to somehow figure out how I'm going to draw this triangle. For me, I'm just going to call this the A of 7. And then I have a 5, so not as long. So I'm going to go B is 5, and then not as long. C is 4. All right, and I'll just cut it back, and that'll work. So therefore, this is angle A, this is angle C, and this is angle B. Now again, your drawing may not look exactly like mine, but it's going to be, I mean, it has to be somewhat like that. Okay, I have side, side, side is what I have. So because I have side, 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 I got to use the law of cosines. So I'm going to use the law of cosines to begin to get my sides, right? So let's do, to begin to get my angles. So I can choose any angle I want. Let's start with angle A. So to get angle A, just to be clear, it's going to be A squared equals B squared plus C squared minus 2BC cosine angle A. And this is what I'm after right there. So the way I like to do these is I'm going to end up with cosine to the negative 1 and so I got to move everything else to the other side. So watch, I have my A squared, my 7 squared. I got to move this to the other side, so that's minus my B squared. I've got to move this to the other side, minus my C squared. And then I have to divide, right, multiplier of the variable, by negative 2 times B, 5, times C, 4. So it's cosine the negative 1 of all that. Let's see if we can punch this in and get a correct answer for the measure of angle A. All right, so 49 minus 25 minus 16 divided by negative 40. All right, and inverse cosine. Make sure you're using cosine, not law of sines. The measure of angle A is approximately 101.5 degrees. 101.5 degrees. All right, so that's my first solution, and that's right there. Okay, cool. That even looks like 101.5 degrees. Now I got to do the exact same thing for angle B or angle C. So I'm going to do angle B. So again, B squared equals A squared plus C squared minus 2AC cosine angle B. And so once again, this is going to be cosine to the negative 1 of my B squared, 5 squared. See how it helped me putting the letters in? I don't know if I did that in the notes, but it definitely helps. B squared, and then minus my A squared, which is my 7 squared, minus my C squared, which is my 4 squared, all divided by negative 2 times my A, which is my 7, times my C, which is my 4. And all of that will approximate the measure of angle B. Okay, so punching all this in. 25 minus 49 minus 16 is a negative 40 divided by a negative 56. I'll just divide it by the 2 and divide it by the 7 and divide it by the 4. Okay, and then inverse cosine. And I got approximately 44.4 degrees. Okay, so now I got my second angle. Now, I can use the law of cosines again to get angle C, or I can simply do angle C. I'm going to do it right here. The measure of angle C is going to be 180 minus the 101.5 minus the 44.4. So that's what I'm going to do. 180 minus 101.5 minus 44.4 equals 34.1. And this is still an approximation. So measure of angle C approximates 34.1. Now, the book says 34.0 because I'm guessing they used the law of cosines, and the round off was a little bit different. I'll take that either way. No answer is better, I think, than the other. Probably 34.0 using the formula. Doing the three angle thing is a little bit of a shortcut. But it does get my angles to add up to 180, right? And we know all three do indeed add up to 180. Again, the discrepancy there is with the round offs. All right, that's number 9. I know a lot of work there, but that's what you got to do to complete that problem. Number 10. All right, we got to set this triangle up again. So we got angle A. So I like to do that angle first at 56. We have a side B of 8. I'm going to stick my 8 here. And then we have a side C of 6. Oh, that's A. So C has to be here. So C is 6, and this is going to be A, and this is angle A. Okay. So that's our scenario. That's our setup, and we're going to go about getting all the rest. So right now I'm looking at this and I say, I know an angle, but I don't know its opposite side, and I don't know another angle. I have to use the law of cosines. So I got to use the law of cosines, and the first thing I got to go after on this is side A. This is what I have to go after first. And it's just because of what they gave me, what I have. So I'm going to use the law of sines. A squared equals B squared plus C squared minus 2BC cosine A. And so again, A is then going to be the square root. So A is going to be the square root. My B squared is 8 squared, plus my C squared is 6 squared, minus 2 times 8 times 6, times the cosine of 56 degrees. That's a 56. All right, let's see if we can punch it in. All right, be careful, that whole back part is negative. All right, so I'm going to end up with the square root of like 46.3. And I got approximately 6.8. Approximately 6.8, and that is correct. So side A is approximately 6.8. Okay, so now I have a 6.8. I can at this point use the 6.8, trusting it, and use the law of cosine or law of sines. Law of sines is easier, and that's what I'm going to do. So now let me go after angle B. So the sine of B over the value of B, 8, will equal the sine of A, 56, over the value of A, 6.8. Now again, the approximations here, right? That 6.8 was a round off. So we're going to be a little bit off, but it's close enough. 56 sine times 8 divided by 6.8. I mean, no matter what you got to do, you got to use these round offs. Now again, be careful. Whenever you go after the angle, let me write this up to be clear. The measure of angle B is going to approximate sine to the negative 1 of, stop, of, give me what I need of this value, right in here. So sine to the negative 1, and I get 77.2 degrees. 77.2. The book says 77.0. Ah, okay. If I used a better approximation of A, I'd probably be there. Let me punch this one more time. 56 sine times 8 divided by 6.8 inverse sine. Yeah, I get 77.2, and that's what we're going to go with. Measure angle B approximates 77.2 degrees. Again, the book said 77.0. I would take it either way. And now I'm just going to use the 3 angles of a triangle equal 180. So the measure of angle C is going to be 180 minus my 56 minus my 77.2. And that is going to give me what? 46.8 degrees. 180 minus 56 minus 77.2, 46.8 degrees. Again, the book used the exact value of A, which again, if I left the value of A in my calculator right here, left it in there, then I could have used that down here and got closer to the actual value. Okay, either way is fine. Those approximations are fine, and I take those either way, as long as you understand we're approximating, and this is where we're ending up. All right, I know, long video. Hang in there. We got more to go, right? Got a few more problems. 11. So round answers nearest 10th. List all possible solutions for the ambiguous case again. So we got to take a look at this. And let's see if we can draw up this triangle. So we have a very acute angle here of 29 degrees. The opposite is a 4, right? Because C is 4. And somewhere it has to be a B of 5, which is the smallest side. I'm going to put B here equals 5. Okay. You got to look at this scenario, and you have to wonder if we've got an ambiguous case. So this would be the A, and this would be A. And I could have put the 5 there. You know what? I'm going to do it that way. You could set it up this way if you want. A is going to go there. Let's see. I'm going to put the B here. And you can put it that way if you want. I'm going to put the B here. B equals 5. I know it doesn't look quite right, but it's going to make life easier on me, and I'm going to put the A there. Okay. Here's what I want to show you. Here's the scenario where that 4 could swing in as well. And this is going to be the ambiguous case. So we got to be careful. Now we got a lot of values to go here. Okay, let's just treat it regular right off the bat. So I want to see what I can use here. Law of sines, law of cosines. Okay, I can use the law of sines to get the measure of angle B. So the sine of B over the value of B, 5, equals the sine of C, 29, over the value of C, 4. Multiply both sides by 5 over 1. Now again, be careful. That's not the sine of 29 times 5. That's the sine of 29.48, whatever, times the 5. And then divide by the 4. Okay, and then remember, this is an angle, so it's going to be sine to the negative 1 of all of this. So I'm hitting my sine to the negative 1 button. And measure of angle B is approximates 37.3 degrees. 37.3. Okay, I can get angle C by the 3 angles of a triangle equal 180. So 180 minus the 29 minus the 37.3, and now I'm at 113.7. Okay, there's one more piece I'm missing, and that's the value of side A. I'm going to use the law of sines. Side A over the sine of A. What did I just do? I called that angle C. That should be angle A. All right, fix that up. So side A over sine of A, 113.7 degrees, is going to equal side C. I always like to use what I was given, over the sine of 29 degrees. All right, so move this to the top. So sine 113.7 times 4 divided by the sine of 29. And I get approximately 7.6 by rounding off to 1 decimal place. And there's my 6th value of the first triangle of the ambiguous case. Now, let me just make my drawing a little bigger for you down here. So this is basically what we have here. We have C here of 4, but that C can come in here at 4 as well. Now, this C did not change. It was 29. This value of B equal 5 will not change. It is a 5. All right. Let's see the way I set this thing up. So this is B and this is B prime. And the big angle is A, and in here is A prime. Now I hope that makes sense to you. So watch what happened. We found the measure of angle B. I'm going to go back and use some color to be 37.3. And because this is an isosceles triangle, the base angles are congruent, and this is 37.3. Therefore, now I can find my new B prime. And it's going to be 180, because they're supplementary angles, minus 37.3. So 180 minus 37.3, and that's 142.7 degrees. 142.7. Okay, we got B prime. How do you get A prime? The three angles of a triangle equal 180. So A prime is going to approximate 180 minus the 29 for C minus the 142.7 for B. Okay, so punching that in, I get A of 8.3, a little itty bitty angle. So the measure of angle A approximates 8.3 degrees. Okay, we are close now. We have one thing left, and that is, let me use color here, A prime. Side A prime has changed. Watch, go back up to the top drawing. See how that was A, but now A prime is only right there. So now I got to find the value of A prime. I'm going to use the law of sines. A prime over the sine of angle A prime, 8.3 degrees. Now I'll go back to C again, equals side C 4 over the sine of C, 29 degrees. All right, move this to the top, sine 8.3, and punch that out. So 8.3 sine times 4 divided by the sine of 29 equals, and I get 1.9. I'm off here. Something is, what number did I use that is off? Let me check all my values. All right, let me punch this one more time. 8.3 sine times 4 equals, divided by 29 sine. Be careful you hit the right buttons. There we go. And we get A prime, I'll just keep it in green, equals approximately 1.2. And there you have it. So we solved the triangle, including the ambiguous case. All right, very, very interesting. Shoo! I know these are long. Hang in there. We got 12 to go and then 13, 14. All right, let's see how we're doing here in 12. Hopefully it's not the ambiguous case. All right, so we got A is 52 degrees. All right, so again, I like to put A there, 52. I know side A is 3. Okay. It's supposed to be 3. I'm already wondering here, but we'll see. All right, and side B is 4. Okay, I can put B anywhere I want. I'm going to stick it here and put the B there, 4. Okay, in this scenario, I know enough to use the law of sines to get angle B because I have its opposite and I have A and its opposite. So let's use the law of sines. So the sine of angle B over side B 4 equals the sine of 42 over its side 3. Now again, be careful. The measure of angle B is going to be sine to the -1 of, and you got to move this 4 right to the other side, and I should put it in the front because it's safer in the front. So 4 times the sine of 42 divided by 3. So let's punch it out. So 42 sine of 42 times 4 divided by 3 equals, all right, 12. I must hit the wrong button. 42 sine times 4 equals, divided by 3 equals, okay, 0.89 inverse sine, 63.1. What did I do wrong? 52. Oh, brother. Would help if I get the right angle. 52, 52, 52. All right, let's try this again. Sine of 52 times 4. Divided by 3. Now I'm looking at my calculator. I have not done sine to the -1 yet. And my calculator reads 1.05. Do you remember the range of the sine? What's the highest value, lowest value? Do you remember it's 1 and -1? And my calculator reads 1.05. So I know when I hit my sign the -1 button, I'm going to get an error. And indeed I did. So what happens when your calculator tells you an error? No triangle exists. So that's an impossibility to have angle AB 52, side AB 3, and side B be 4. No triangle exists. It's an impossibility. Really what happens is that side A can't reach the other side of the triangle. It's not long enough to reach down and hit the side. And so the triangle is not complete. It doesn't exist. It can't happen. And no such triangle exists. All right, awesome. All right, 13. How far apart are the legs of a 12-foot step ladder if the angle between the legs is 19 degrees? All right, so draw a picture, draw a picture, draw a picture, draw a picture. Step ladder, right? Those are the legs. 12-foot step ladder. 12 foot, 12 foot, 19 degrees. How far apart are their legs? I think that's your problem, right? So I'm just going to call this X. And so I'm going to have to use the law of cosines, right? Call this Y and I'll call this Z. So X squared equals Y squared plus Z squared minus 2YZ. Cosine, law of cosines, 19 degrees. And again, be careful. You can take the square root of both sides. So X is going to be the square root of Y squared, 12 squared, plus Z squared, 12 squared, minus 2 times 12 times 12 times the cosine of 19 degrees. All right, let's punch this baby in. 19 cosine times 12 times 12 times 2 negative, all right, plus 144. Again, punch in the way you want to. This is the way I do it. Plus 144. All right, so it's the square root of 15.69, and I get approximately 4.0. And again, I should put 4.0, not just 4. So approximately 4.0 feet is the answer. And that's how far the legs on the ladder would be spread. Law of cosines. 1 to go. All right. Hang in there, long video. Mr. Davis wants to enclose a triangular field with electric fencing. A survey of the adjacent field shows that the other field is at a 112-degree angle with the roadway, and that the length of the shared side is 212 feet. If his lot road frontage is 156 feet, how much fencing does he need to enclose the field? Okay, so we already know he's going to use 156 feet for that part. He's going to use 212 feet for that part. And therefore, then the question is, how much is he going to use for that part? All right, be careful here. Make sure that you see the supplementary angles right there, right? So if this is 112, the angle in here is 180 minus 112. So what is that? 68 degrees. Okay, so I have an angle. I'm looking for its opposite, and I have two sides. I got to use law of cosines. So again, to help myself, I'll call this, whoops, not X. I already have an X. I'll call that Y, and I'll call that Z. So X squared equals Y squared, Y squared, X squared. And you can use A, B, and C if you want to. Y squared plus Z squared minus 2YZ cosine X. And again, to get to X, we're going to take square root of both sides. So X equals the square root of what is my Y, 212, excuse me, squared plus 156 squared minus 2 times 212 times 156 times the cosine of 68 degrees, not 112. All right, 68 cosine times 156 times 212 times -2 plus 156 squared plus 212 squared equals, all right, like 4,000, 44,000. Hit the square root button, and I got x equals 211.0 is my round off. It's nigh an isosceles triangle. But be careful now, we got to get a final answer. So we found this to be 211 feet. So you got to add up all three, right? How much fencing does he need to enclose the field? So 211 plus 212 plus 156. He's going to need 579 feet of fencing. All right, law of sines, law of cosines. We also talked about how to find the area of an oblique triangle. All right, and so you don't know the altitude to use regular area of a triangle equals 1/2 base height, but we can use the law of sines instead to get there. So don't forget the area formula for an oblique triangle. Law of sines, law of cosines, and then don't forget the ambiguous case. All right, these are the key aspects so far to this chapter. Now we're going to get into some trig identities, and I don't go deeply into them. In advanced math next year, you will. Those of you that will take advanced math next year, you'll go in detail into the trig identities. So I'll just introduce it to you in this course, and then we get to the last half of the chapter, trig equations, and they're the key. So that's where we're heading. So know your law of sines, know your law of cosines, know your area formula, know the ambiguous case, learn a few of the key trig identities, and then we're ready for trig equations. All right. Hope you're having a good, a safe time at home, and hopefully this quarantine will end soon. Maybe we'll be able to have a real graduation, where at least we're going to have a drive-in, and we'll see what happens. All right. Lord bless you.